Okay, let's take a look at the last question in sample exam 2, Chem 11. This question says that we have a 1.5 gram mixture of solid sodium chloride and solid sodium nitrate in a beaker, okay? And then we add water to it to completely dissolve both of those salts, and then we add excess amount of silver nitrate, then some reaction occurs, and we see a white solid as a product, and weigh that to be 0.641 grams. And the question, there are 3 different parts. First, we just have to write all the different species, and then afterwards we have to write any net ionic equation and balance equation that we have, and then we have to calculate the percent by mass of the sodium chloride. So let's draw this out. It's always helpful to kind of see what's going on. So first we have our mixture of 1.5 grams, and this contains both sodium chloride and sodium nitrate. We put some water in here, and these both, you remember from solubility rules, are soluble salts, so they're just going to dissolve. And then after they dissolve, we add silver nitrate, which is AgNO3, and this is added in excess, and as a result of that addition we form a white precipitate, and the white precipitate is 0.641 grams. Okay, so let's figure out what's going on. The first thing we think about is what happens to the sodium chloride and sodium nitrate when we add water to it. Well, they're both soluble salts, so they're just going to break apart to form ions. So what we'll see is sodium and chloride ion floating around, along with, from the nitrate, sodium and nitrate ion. So that's what's present here in this flask. It's just sodium, chloride, and nitrate. The next question is, what happens to the silver nitrate solution when you add it? Well, silver nitrate is also a soluble salt, so it's going to break apart to silver and nitrate. And so we have an addition. When we put the silver nitrate in the solution, we also now have some silver floating around in addition. The nitrate would just combine with the nitrate that's already in there. So we have these 4 ions that are floating around, and the question is, which of these 4 would end up having a reaction with each other? And so when we say a reaction, we mean that there is a solid product, because we know that at the end we make this precipitate. So we want to know which of these ions would react with each other that would end up giving us a solid product. So this requires you to remember solubility rules again, and you find that the 2 that would combine to form a solid is silver ion and chloride ion, forming the precipitate silver chloride. Okay, so now that we know what's going on, we can answer question A, which is just to write down all the species and their phases that are present in the beaker after the reaction is complete. You should have AgCl, that's your solid, sodium floating around, nitrate, and you should have some leftover Ag+, because remember you're adding excess silver, so that would be left over from the addition of the silver nitrate. Now these ions are all aqueous, and then the silver nitrate would be a solid. And if you want, you can also say that you have a lot of water in the solution, because that's your solvent. The second question is about writing reactions. So the question is, write the reactions that produce the precipitate. Well, there are several ways to write it. The net ionic we actually already wrote right here, but we can start by writing the molecular equation, and that's just going to be AgNO3, and the thing that reacts with it is the NaCl in a molecular form. So that forms AgCl and NaNO3 aqueous. Your complete ionic would be Ag plus NO3 minus, Na plus Cl minus, AgCl, and Na plus NO3 minus. And I can remove my spectator ions, which is nitrate and sodium. So my net ionic is Ag plus Cl minus goes to AgCl solid. The last question says to calculate the percent by mass of sodium chloride. So we can do that, reversing the calculation. We know that we made this much silver chloride, so we can use that to calculate how much sodium chloride we have. That's a 1-to-1 stoichiometry using this molecular equation right here. So we would just say the mass of sodium chloride is going to be, start with the mass of silver chloride divided by its molar mass, which is 143.32. That gives you the number of moles of silver chloride, and then we're going to convert this to number of moles of sodium chloride, and in the reaction that's a 1-to-1 stoichiometry, and then lastly we'll multiply this with the molar mass of NaCl. You end up getting 0.25998 grams, and that's NaCl. So then to get the percent NaCl, you would take this number and then divide by the original mixture, which is 1.5 grams times 100%. So that will give us 17.3%. Okay,